Welcome to this video. In this video, we're going to prove this result that every Cauchy sequence in real number is convergent. We already know that every convergent sequence is Cauchy, but in real number, the converse of it is also true. That is, every Cauchy sequence is convergent. We want to prove this result for every Cauchy sequence. So we start the proof by taking any Cauchy sequence in R. So let my an be any Cauchy sequence in R, that means real number. I want to prove this is convergent. But by the definition of Cauchy, we know that what is the definition of Cauchy sequence? That means for every epsilon greater than 0, if you have epsilon greater than 0, then there will exist a natural number k greater than 0 such that my mod of an minus am will be less than epsilon for all n comma m greater than or equal to k. Right? So this is by the definition of a Cauchy sequence. I want to prove this is convergent. To prove it is a convergent, first of all we will prove that Cauchy sequences are bounded. So what I claim is, I claim that this sequence, which is a Cauchy sequence, is bounded, because this will help us to prove it is convergent, because we know that every bounded sequence on R has Bolzano-Weierstrass property. We are going to use Bolzano-Weierstrass property, hence we will show it is a bounded sequence. So I want to prove it is bounded. For that I will use this definition. The definition tell me for every epsilon greater than 0, so I will choose for epsilon equal to 1, there will exist some number, suppose that number is k1 greater than 0, such that my mod of an minus am is less than epsilon. Epsilon is 1, so I will replace it by 1 for all n and m greater than or equal to k1. Okay. Now by using this, I want to prove it is bounded. So what I observe is, by triangular inequality, I will have my mod of an is less than or equal to mod of an minus a k1. This k1 is nothing but this k1 plus mod of a k1. Correct? So this is true by triangular inequality. Also, for n greater than or equal to k1, I know that my mod of an minus a k1 would be less than 1 by using this. Therefore, my mod of an is less than 1 plus mod a k1, and this is true for all n greater than or equal to k1. So what we found is, after a finite number k1, every other number is bounded. Correct? After a finite number k1, every other number in the sequence is bounded, and rest of the numbers, since they are finite, they are also going to be bounded. We will just write it properly. Correct? So what I do, let my capital M be equal to the maximum of the mod of a1, mod of a2, mod of a k1. So these are nothing but the finite numbers, and after this all the numbers are bounded by 1 plus mod of a k1. Now from this list I will choose a maximum and give it a name as m. Now this m will satisfy this property, my mod of an is less than or equal to m for all n inside natural numbers, and this implies me my sequence is bounded. Correct? Now we found the sequence is bounded. Since bounded sequence in R, that means real number, satisfy Bolzano-Weierstrass property. What is Bolzano-Weitra property? It tells that every bounded sequence in R has a convergent subsequence. Implies An has a convergent subsequence. Now it has a convergent subsequence, right? So let my A N P be the convergent subsequence, of An converging to a point, say A. Correct? So it has a convergent subsequence. I give it as a name as ANP, and it is converging to A. Ultimately, what I wanted to prove that every Cauchy sequence is convergent. So now we come to the main claim. We will claim that my given sequence is convergent to A. I want to prove wherever my subsequence converges, at the same point my sequence also should converge. Okay. Now this is a subsequence and it is converging to A. Correct. That means it will satisfy the epsilon definition of it. Correct. Okay. So we'll use that definition. Before that, I just go for An converges to A. So let's just work on this. An converges to A. So what I do, I just consider for any fixed epsilon greater than 0. I consider any fixed epsilon greater than 0. Since my epsilon is greater than 0, my epsilon by 2 is greater than 0. Okay. So since my epsilon by 2 is greater than 0, for this, by using this, since it is converges to A, for epsilon by 2 greater than 0, there will exist some n1 such that my mod of, since my A and P converges to A, my mod of A and P minus A is less than epsilon by 2 for all P greater than equal to n1. Okay, so what I used that my this subsequence is convergent. Since my epsilon by 2 is greater than 0, there exists n1 such that this distance between A and P and A is less than epsilon by 2. Also, we have na that An is Cauchy. We'll use the definition of Cauchy. Since my epsilon by 2 is greater than 0, there will exist some n2 such that my mod of An minus Am is less than epsilon by 2 for all n and m greater than equal to n2. Okay. Now we have n1, we have n2. What we do? We choose capital N to be maximum of n1 and n2. What is the advantage of doing it? If my n is maximum of n1 and n2, then both the property is true for all p, n and m greater than this capital N. Okay, so what I did, I just took maximum of this n1 and n2 and give it as a name as capital N. Okay, therefore my mod of A and P minus A is less than epsilon by 2, and mod of An minus Am is less than epsilon by 2 for all P, N, M greater than this capital. We will be using this to prove what we want. What we want to prove? We want to show that my An converges to A. So I just consider the difference between this. So mod of An minus A. Can I say this is less than mod of An minus A and P plus mod of A and P minus A? Okay. Here one thing student should note. Since my NP is greater than P. Why NP will be greater than P? Because my NP is nothing but subscript for the subsequence. Correct? So since my NP is greater than P and it is greater than N, I can tell this is less than epsilon by 2, and also this is also less than epsilon by 2 for all N greater than capital N. From this we use it. Okay. So what I found, therefore I found that my mod of An minus A is less than epsilon by 2 for all N greater than N. That means what? That means my sequence An converges to A. This was a given Cauchy sequence which is convergent. Hence the proof is done. Okay. If you understand the proof, please let me know in the comment section if you have any doubt. Okay. Thank you.